Hello friends, welcome back to Cloud Pedagogy. In last few sessions, we have got a very good understanding of AWS code commit in our course. Before going to the next level of CI/CD, I would like to discuss about an IDE. If you are an experienced developer, of course, you probably already know why using an IDE is a great idea. But if you are completely new to the software development world, you may not even know what an IDE is. Well, not to worry, in this course I will explain what an IDE is and why you need to start using one. Developers are a finicky bunch. Prior to IDEs around 1980s, programmers wrote their programs in the text editors. They were the primary tools used for coding. Of course, those tools were kind of manageable. Those involved writing and saving an application in the text editor before running the compiler, taking note of any error messages, and then going back to the text editor to revise their code. In reality, as a developer, do you really think that these things are done faster with these kind of tools? I kind of doubt that. That's where IDEs comes into the picture. What is an IDE? An integrated development environment, which is IDE, is a software application that helps programmers develop software code efficiently. It increases developer productivity by combining capabilities such as software editing, building, testing, and packaging in an easy to use application. In a simpler way, just as writers use text editors and accountants use spreadsheets, software developers use IDEs to make their job easier. And if you have done any kind of development, of course, you certainly know what an IDE is. So, why are IDEs important? You can use any text editor to write code. However, most IDEs include functionality that goes beyond texting. They provide a central interface for common developer tools, making the software development process much more efficient. Developers can start programming new applications quickly instead of manually integrating and configuring different software. They also don't have to learn all about the tools. Instead, they can just focus on one application. We'll see some of the reasons why developers use IDEs. Code editing automation. Programming languages have rules for how statements must be structured. Because an IDE knows these rules, it contains many intelligent features for automatically writing or editing the source code. Next, syntax highlighting. An IDE can format the written text by automatically making some words bold or italic, or by using different font colors. These visual cues makes the source code more readable and give instant feedback about accidental syntax errors. Next, intelligent code completion. Various search terms show up when you start typing words in a search engine. Similarly, an IDE can make suggestions to complete a code statement when the developer begins typing. And next, refactoring support. Code refactoring is the process of restructuring the source code to make it more efficient and readable without changing its core functionality. IDEs can auto-refactor to some extent, allowing developers to improve their code quickly and easily. Other team members understand readable code faster, which supports collaboration within the team. Next, local build automation. IDEs increase programmer productivity by performing repeatable development tasks that are typically part of every code change. Here you can see some examples of regular coding tasks that an IDE carries out. Compilation. An IDE compiles or converts the code into a simplified language that the operating system can understand. Some programming languages implement just-in-time compiling, in which the IDE converts human-readable code into machine code from within the application. Next, testing. The IDE allows developers to automate unit tests locally before the software is integrated with other developers' code, and more complex integration tests are run here. Next, debugging. Debugging is the process of fixing any errors or bugs that testing reveals. One of the biggest values of an IDE for debugging processes is you can step through the code, like line by line, as it runs and inspect code behavior. IDEs also integrate several debugging tools that highlight bugs caused by human error in real time, even as the developer is typing. Next, what are the types of IDEs? IDEs can be broadly classified into several different categories depending on the application development they support and how they work. However, many IDE software applications can fit into multiple categories. Let's focus on most widely used IDE types like local IDEs and cloud IDEs. Local IDEs. Developers install and run local IDEs directly on their local machines. They also have to download and install various additional libraries depending on their coding preferences, project requirements, and development language. While local IDs are customizable and do not require an internet connection once installed, at the same time they present several challenges, such as they can be time consuming and difficult to set up. They can consume local machine resources and can slow down machine performance significantly. Configuration differences between the local machine and the production environment can give rise to software errors. Next type of IDE is cloud IDEs. Developers use cloud IDEs to write, edit, and compile code directly in the browser so that they don't need to download software on their local machines. Cloud-based IDEs have several advantages over traditional IDEs. Let's see the advantages. Standardized development environment. Software development teams can centrally configure a cloud-based IDE to create a standard development environment. This method helps them avoid errors that might occur due to local machine configuration differences. Next, platform independence. Cloud IDEs work on the browser and are independent of local development environments. This means they connect directly to the cloud vendor's platform and developers can use them from any machine. Next, better performance. Building and compiling functions in an IDE requires a lot of memory and can slow down the developer's computer. The cloud IDE uses compute resources from the cloud and frees up the local machine resources. But you might be wondering, how should I choose an IDE? You can find many modern integrated development environments on the market with a range of features and different price points. Many IDEs are open source or free to use and configure, but there are some criteria to consider when choosing an IDE. The programming language. The programming language you want to code in often dictates the choice of an IDE. Dedicated IDEs have automation features that particularly suit the syntax of specific languages. On the other hand, multi-language IDEs support multiple languages. Next, the operating system. While most IDEs have multiple versions for different operating systems, they might work better on specific platforms. For example, some IDEs can perform optimally on the Linux platform but might be slow or difficult to use on the other platforms. Next, automation features. The three common features in most IDEs are the source code editor, build automation, and debugger. Additional features like code editor UI enhancements, automated testing features, code deployment support via plugin integration, code refactoring support, application packaging support helps to improve your development process. Next, IDE customization. Some IDEs include the ability to customize workflows to match a developer's needs and performances. You can download and use plugins, extensions, and add-ons to customize your programming experience. So by now, you might have realized how good IDEs are, right? So let's understand an IDE that's actually provided by AWS in the next session. Until then, take care and keep learning.